Hello students, let us learn about the properties of long form periodic table. In the previous video, we have understood that in the year 1913, Henry Moseley suggested that elements should be classified on the basis of atomic number. And Mendeleev's periodic law was modified to modern periodic law, which states properties of elements are periodic function of their atomic number. We also understood that elements show a repetitive characteristics due to their periodicity in the electronic configuration. Now let's understand more about the long form periodic table or the modern periodic table that we are using now. In modern periodic table, elements are arranged in the increasing order of their atomic number. The first element is hydrogen with atomic number 1, and then you can see that elements are arranged in the increasing order of atomic number. The modern periodic table consists of 7 horizontal rows called as periods and 18 vertical columns called as groups. As we know that atomic number is the basis of classification in modern periodic table, we can also state that elements are arranged based on their electronic configuration. And this arrangement of elements provides a systemic pattern in the electronic configuration of their valence shell. Now let's learn about the characteristics of periods. As we have already discussed, there are 7 periods in periodic table. Elements have consecutive atomic number. That means the atomic number of elements in a period is increasing by 1. Every period starts with an alkali metal and ends in a noble gas. So we can define a period as a series of elements arranged in the increasing order of atomic numbers, beginning with alkali metal and ending with noble gas. Elements in a period have same number of shells and different number of valence electrons. So, this difference in the number of valence electrons give rise to different properties in the elements present in a period. Now, here is an example given to you. Here are 8 elements taken from second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So, if you see, all these elements have 2 shells, K shell and L shell. In all these elements, the K shell is filled, but in the L shell, the electron gets filled one by one. So for lithium, the configuration is 2-1 and its valency is 1. Whereas for boron, it is 2-3 and its valency is 3. So for all these 8 elements, the valency is different. And this difference in the valency or in the number of valence electron give rise to different properties in the elements. So if you see, lithium, beryllium and boron are metals. Carbon, nitrogen, oxygen, fluorine and neon are non-metals. And in that, neon is a noble gas. Fluorine is highly reactive non-metal. Lithium is a highly reactive metal. So in the same period, you have a highly reactive metal, a moderatively reactive metal, a highly reactive non-metal and a noble gas. Before moving on to the next characteristics of period, let us recall the 2n square rule. 2n square rule determines the number of electrons which can be accommodated in each shell in an atom. So if n is the number of shell, then the number of electrons that can be accommodated in each shell is 2n square. So if K shell is the first shell, the maximum capability or capacity of K shell is 2 electrons and of L shell is 8 electrons. So that is why in the first period you have 2 elements, in the second period you have 8 elements. So number of elements in a period is fixed by the maximum number of electrons that can be accommodated in the outermost shell. Now the outermost shell of elements present in the first period is K shell and it can take only 2 electrons. So there are only 2 elements in the first period. For the second period, outermost shell is L and its capability is 8. So it has 8 elements. The first period in the long form periodic table is the very short period which consists of only 2 elements, hydrogen and helium. In both of these elements, K shell is present and electrons are present in the K shell. Hydrogen has 1 electron and helium has 2 electrons. That means helium's configuration is complete. The second period is a short period with 8 elements. It starts from lithium and it ends in neon. There are 2 electrons in K shell of all these elements, whereas electrons get filled in the L shell. The third period is again a short period with 8 elements. It starts from sodium and it ends in the noble gas argon. All these elements have 3 shells K, L and M. The K and L shells are completely filled, whereas electron gets filled in the M shell one by one. Now, naturally a question arises. Why does the third period contain only 8 elements even though the electron capacity of third shell is 18? We know that according to 2n square rule, M shell can accommodate 18 electrons. But according to the octet rule, we know that the last shell should have only 8 electrons. And for the third period elements, M shell is the outermost shell. Hence, it can take only 8 electrons in this case, and that is why the third period have only 8 elements. Moving on to the fourth period, it is a long period with 18 elements. It starts from potassium and it ends in krypton. Potassium is an alkali metal and krypton is a noble gas. A few elements starting from scandium to copper are known as transition elements in this period. Similarly, the fifth period is also a long period and it starts from rubidium and it ends in xenon. There are also transition elements in the fifth period. The sixth and seventh period are very long period with 32 and the rest of the elements. 14 elements after lanthanum in the sixth period and 14 elements after actinium in the seventh period are kept separately from the periodic table. The reason for this placement is to do with the electronic configuration of these elements, which you will learn in your higher classes. So let's summarize the characteristics of elements in a period. In a period, all elements have same number of electron shells. The consecutive elements differ by 1 electron. Every period starts with an alkali metal and ends in a noble gas. The number of elements in a period is fixed by the maximum number of electrons that can be accommodated by the outermost shell of the element present in that period. Moving on to the groups in a periodic table. We have understood that groups are vertical columns seen in a periodic table, and in the modern periodic table you have 18 vertical columns. The first two groups and the groups from 13 to 17 contain normal elements, which are also known as representative elements. Groups 3 to 12 consist of transition elements. All the members in a group have same valency. The elements from group 3 to 12 are called as transition elements because the outermost shell as well as the shell next to outermost shell called as the penultimate shell are incomplete. So electron gets filled simultaneously in both these shells. Now let's learn the names of these groups. The first group elements are called as alkali metals. Second group elements are called as alkaline earth metals. Groups 3 to 12 are known as transition metals. 13th group is known as the boron family, 14th group is called as the carbon family, then nitrogen family, 16th group oxygen family, the 17th group elements are called as halogens and the 18th group elements are known as noble gases. The lanthanides and actinides which are kept below the main form periodic table are known as inner transition elements. We already discussed that the valency of elements in a group is same. Alkali metals have 1 valence electron and their valency is 1. Group 2 elements have 2 electrons in the outermost shell and their valency is 2. Group 13 elements have 3 electrons in their outermost shell and their valency is 3. Carbon family have 4 valence electrons and the valency is 4. The elements of nitrogen family have 5 valence electron but their valency is 3. That is, they require only 3 more electrons to complete the octet. Group 16, the valency is 2. 17, the valency is 1. And group 18 are 0 valent element. Here is a comparison between the period and the group elements. You can see that in a period, the number of shells are same but the valence electrons and valency is different. And in a group, the valence electrons and the valency is same. Let's see the position of hydrogen in the long form modern periodic table. Hydrogen is placed with group 1 as its valency is 1 and its atomic number is also 1, and it is the first element. But hydrogen is not considered as an alkali metal due to its difference in properties. It is much smaller in size than the alkali elements. In certain representations, hydrogen is not placed in any group and it is given a special place. So, the position of hydrogen is still an anomaly in the modern periodic table. Placing lanthanoids and actinoids outside the periodic table is also an anomaly of this modern periodic table. So children, we should understand that it took time for the periodic table of elements to develop into its current form, and many of its early iterations like this one called as Mendeleev's flower would be an unrecognizable thing today. I hope that you have understood the characteristics of periods and groups in a periodic table. Thank you for watching this video. If you like this video, do hit the like button and share the video among your friends and family. Also show your love and support by subscribing the channel. Do not forget to hit the bell icon so that you get instant notifications when the videos are uploaded. Also, check the links of the playlist for term 2 portions of class 10 physics and chemistry in the description below. See you all in another video.